Welcome everybody to ST's MOOC Open online course about low voltage motor control. So here we see in this diagram the main components we need for motor drive. On the right side we can see the engine. Left from this we see the driving section where we have the drivers and the MOSFETs. And left from this we have the power management with DC-DC converter or LDOs, the microcontroller, which will not be part of this presentation, and also the signal conditioning, which can be done via op-amps and comparators, for example. Ensure and fit the needs of the industrial market, ST offers a longevity program for motor control ICs. There we have different commitments from 7 up to 15 years for different product lines. This ensures that the customer can reuse our product without having the fear that the product may vanish from one day to another. This is to meet the requirements in the industrial world. Offering also an ecosystem to evaluate different components quite easy. Here we leverage on the X-Nucleo system, which can be combined with a Nucleo board. And as we can see here, we see the boards in the middle. If we combine the X-Nucleo with the Nucleo board, we just have to plug in the power supply to the X-Nucleo board and the motor and connect the Nucleo board with the laptop. Dedicated firmware to run the different kind of motors ST is also offering and are free available on st.com. Let's start with the first point, the power management. Here we will have a closer look on the switching regulators and motor control application. These switching regulators are needed to convert the voltage to supply the driving section. And if we look on the right on the diagram, we see a lot of different products for different voltage range with different current output in different housings. And as we all know, especially in the beginning, for young engineers, it can be quite hard to find the right product for your application. Due to this, ST is offering the e-design suite. And there we see the power supply design tool. It's free available on st.com and it works quite easy. You just have to choose the type of power conversion you're looking for example, DC-DC, AC-DC, put in the voltage you need and the current output, and the tool gives you the best solutions for your applications ST has to offer. This makes your life much easier, and especially in the beginning, this is a good tool to find very fast the best choice for your application. The next product family for power management in motor control are the linear regulators, or short LDOs. An LDO is a cost-effective solution for converting a high input voltage into a lower output voltage. They are needed when your application requires a clean voltage rail for signal conditioning, to power a microcontroller, and many more other use cases. But how to choose the right one for your application? That always depends on your need and on the requirements of your application. On the right, you can see some suggestions of product families for different use cases. If you look, for example, for system efficiency and a minimum power dissipation, our LD39X family could be right for you. You just need a simple and cost-effective product, then you should consider our LDK or LDL families. To make the decision for the right product as easy and convenient as possible for our customers, ST offers a product finder called ST VRAC Finder, which can be downloaded for your mobile device. It can help you to find the right product in the right packaging depending on your needs. Signal conditioning in motor control means mainly current sensing, and it's quite often overlooked. But it's worth to have a deeper look at it because the right choice can bring benefits. The high precision op-amp family, TSZ, enable you to have a much better signal to noise result, so you can use smaller shunts and minimize the losses of the system. Another case where the right choice can bring advantage is when you want to track high slew rate signals. Here you need a high gain bandwidth product like you have with the TSV99 or with the TSV18X families. If you want to have higher robustness for your application, you can go with our TS3X comparator family. This family can be used to build an overcurrent protection, which can shut down the application in an overcurrent situation. To make the life easier of our customers, we have a tool here which can help. It's called STOpamps app, and it's available via mobile phone. Now we come to the core of this presentation, the low voltage motor control section, or also the inverter stage. You see here a more detailed diagram than you saw at the beginning of the presentation. In magenta, you see the products we have already discussed, the power management and the signal conditioning. The control unit or microcontroller unit will not be part of this presentation. But let's start with a simple explanation of the reduced schematic for the motor controller that we see here. Starting from left to right, on the left side is the battery. The voltage supplied by the battery must be converted into the correct voltage for the microcontroller unit and the control unit. The control unit gives the commands to the control logic of the gate driver, which switches the power states on and off according to the inputs of the microcontroller. The power stage supplies the current from the battery to the motor, which can be seen on the right, in the way the microcontroller commands. There are three main types of motors: brushed DC motors, brushless DC motors, and stepper motors. Each motor type requires its own power stage, a gate driver, and a control unit with different control algorithm. To check whether the motor is working as the microcontroller commands, we need the signal conditioning processing to obtain feedback from the motor. There are different approaches to achieve motor control by combining different blocks of the schematics or leave them on their own. Later in this presentation, we will learn more about these approaches. Here is an overview of the ST product portfolio for motor control. ST offers many products for different application and power levels from 10 to more than 1000 watt. For each power level, ST offers different package approach such as monolithic, system in package or controller to provide the best performance and power density for all type of motors and many different applications. We will discuss in this presentation for the low voltage range, which means a battery voltage below 100 volt. We see the different approaches ST is offering to satisfy the customer needs. Depending on the application and mainly on the power output, ST is offering different solutions. Solution 1 is the discrete approach, where we have a standalone microcontroller, a standalone gate driver, and a standalone power section with MOSFETs. The second solution is the integrated power solution. This means we have also a standalone microcontroller, but we have a gate driver where the MOSFETs are combined in a system and package approach or monolithic approach. The third solution is the integrated intelligence solution. Here we combine the microcontroller with a gate driver and have external power stage with MOSFET. This allows us to target higher power, but also have the advantage of the integration. Approach we will have a closer look on is the discrete approach, where everything is standalone. As I said before, the microcontroller will not be the topic of this presentation. So let's have a look on the gate drivers and on the MOSFETs. So here we see our ST Drive 100 family. These are all low voltage gate driver for 3-phase BLDC motors. This means we have 6 driver outputs to drive 6 MOSFET in a half bridge configuration. The first product we will have a closer look on is the ST Drive 100. It's a simple and cost-effective driver with not much features. The next product family is the ST Drive 200X family. This is a high integrated and scalable gate driver family, which is working up to 50 volt. Let's have a closer look on the next slides on these products. The ST Drive 101 is a 3-phase BLDC gate driver. It's a simple and cost-effective driver which comes in a 4x4mm QFM package. It targets applications are BLDC motor applications such as e-bikes, fans, drones, robotics, power tools, and many others. It works from 5.5 up to 75 volt and has embedded LDO, which supplies the logic in the driving section, which is fully protected with the ST typical protections like undervoltage lockout, overcurrent protections, and a thermal shutdown. The gate current of the driver has a sink and source current of 600 mA with embedded bootstrap diodes for all the high sides. It offers 2 different driving methods with a very short propagation delay of 70 nanoseconds and a standby mode to decrease the power consumption. It also offers a VDS monitoring to check that every power MOSFET is working the way it should and communicate all the faults via the open drain pin to a microcontroller. The ST Drive 102 is a family of advanced triple half-bridge gate driver with an improved below ground and overshoot robustness, with target applications such as power tools, e-bikes, portable vacuum cleaners, pumps, and other applications which are driven by a BLDC motor. The family can work up to 50 volt and have adjustable current for source and sink up to 1 and 2 amp. It has 2 embedded LDOs, one for the self-supply and another one for the external component supply such as microcontrollers. The high sides are working with a charge pump which allows the driver to work up to 100% duty cycle and a standby mode with a power consumption lower than 50 nanoamps. All the part numbers of the family comes with the ST typical protections and a VDS monitoring to check the status of all the power MOSFET. In the table below we can see the 4 different part numbers. They are differentiated into a version which is programmable via hardware or via SPI. For the hardware version we have the entry line with 2 comparators and 1 op-amp and the advanced line with 3 comparators and 3 op-amps. The entry line of the SPI has 1 comparator and 1 programmable gain amplifier, which is programmable via SPI, and the advanced version have 3 comparators and 3 programmable gain amplifiers. The entry lines come in a 5x5mm QFM package and the advanced line in a 6x6mm QFM package. The L648X series is an advanced and fully integrated bipolar stepper motor controller with microstepping. It integrates a dual full bridge gate driver for N-channel MOSFET with a non-dissipative overcurrent protection. The controller works from 8 up to 85 volt with adjustable gate current and a charge pump to supply the high side. It has two embedded voltage regulators, one for the control core and one for the driving section. It offers an SPI interface to the microcontroller, sensor stall detection, and a digital motion engine core for programmable speed positioning and many more features. If you look on the table below in the center, we see the two part numbers of the family. The first part number is the L6480, which offers a voltage mode driving algorithm, which allows the motor to work up to 128 microsteps with a smooth and very silent motion. Key applications are industrial pumps, security cameras, 3D printers, and industrial drives. For accurate positioning and higher system stability, the L6482 offers the predictive current control mode with an adaptive decay which works up to 60 microsteps. Key applications are here industrial printers, ATM machine, textile machine, and industrial automation. Before we saw all the gate drivers and controllers which have to be paired with low voltage MOSFETs. Here we can see now the StripFET F7 and F8 low voltage MOSFET families. The families are using an advanced double trench technology which is state of the art, especially in terms of efficiency and power density for low voltage applications. If we look on the right hand side, we can see where each family finds its application. The F8 family goes from 30 to 150 volt with a max RDS on of 10 milliohm for the whole family. Whereas the F7 family has a voltage range from 40 to 100 volt and offers a higher RDS on. All the families are available in the common housing such as Power Flat, D-Pack, D-Square Pack, SOT and many more. Especially in the 40 volt range, our F8 family sets the benchmark for the current low voltage MOSFET market, which can be seen in the diagram below in the center. The two families are designed for high switching frequency, high efficiency and low EMI and can be used partially well in motor control and countless other applications. Now we know which products are behind the solution 1, the discrete approach. Let's come to the second solution, the integrated power approach. The integrated power approach is the approach where we combine the gate driver with a MOSFET. This can be in a system package or in a monolithic approach. Let's have a closer look at the products behind this approach. Here we see now our STSpin 200 family. It's the ideal product for battery-powered applications. Applications such as smartphone, e-walls, e-meters, e-lockers, point of sales, toothbrush and shavers, medical and healthcare equipment, toys, and many more applications. The family contains 5 part numbers, and if we look on the table on the left side, we see the STSpin 220, which is dedicated for stepper motors. It works up to 256 microsteps, which guarantee a smooth and silent motion and also offers extreme positioning accuracy. Below we see the STSpin 230 and 33, which is for BLDC motor drivers, which offers a 1 and 2 shunt solution. Below we see the STSpin 240 and 250, which is a dual brushed motor driver and a single brushed motor driver. All the part numbers work from 1.8 up to 10 volt and have an RDS on of 200 milliohm. The current output is approximately 1.3 amp RMS, and all the products have a standby mode, which is best in class with a power consumption of typically 10 nanoamp which extends the lifetime of the battery. It also offers the ST typical protections like undervoltage lockout, overcurrent protection, and the thermal protection, and all the part numbers coming in a 3x3mm QFM package. The STSpin 800 family is a motor driver which integrates in a small 4x4mm QFM package both control logic and low RDS on power stage. It contains 3 part numbers, one for brushed motors, one for brushless motors, and one for stepper motors. We can see in the table on the left side the 3 different part numbers. There we see the STSpin 820, which is for stepper motor, and it can work up to 256 microsteps to guarantee a smooth and silent motion. The 830 is for 3-phase BLDC motors, which can be used to drive BLDC motors with the 6-step or the FOC algorithm. The STSpin 840 is a dual driver for brushed motors, which can also be used to drive one motor with higher current if we put them into the parallel driving mode. All the part numbers work from 7 to 45 volt and have a current output around 1.5 amp depending on the ambient temperature. They also have a standby mode to lower the consumption, and they come with a bunch of protections like undervoltage lockout, overcurrent, and thermal protection. If we want to go higher in terms of power, you could go with our best-selling motor driver family, the L62XX family. The L62XX family is a DMOS fully integrated motor driver with a non-dissipative overcurrent protection of all the high-side power MOSFETs and a thermal shutdown realized in the BCD multi-power technology, which combine an isolated DMOS power transistor with CMOS and a bipolar circuit on the same chip. The family offers different solutions for brushed motors, brushless motors, stepper motors with different RDS on and current output up to 2.8 and 5.6 amp RMS, and are available in different packages like Power SO, SO20 and 24, Power Dip, and also in QFM to fit perfectly to our customer needs. The family is also scalable in terms of the embedded features, what we can see in the table on the upper right hand side. For the brushed and stepper motors, we can choose between different functions. There we have the X5 with just a fixed overcurrent protection. The X6 offers a programmable overcurrent protection and a diagnostic output. X7 additionally to that offers a twin PWM current control. The X8 is dedicated for stepper motors and it offers a stepping frequency generator. For BLDC motors, we can choose between a programmable overcurrent protection and a diagnostic output, or we can have a Hall sensor decoding logic and speed control output. The devices can be used in many applications, like for example stage lighting, vending and textile machine, ATM and money handling machines, medical equipment, antenna control, factory automation, or small home appliances. The STSpin 9X8 family is a multi-half-bridge motor driver family for brushed motors and bipolar stepper motors with a single and a dual full-bridge version. The power stage of both products is designed with high dynamic and allowing to achieve high-frequency PWM control with precise duty cycle. This is guaranteed due to a charge pump which allows the driver to go 100% duty cycle. The device offers a current limiter with adjustable threshold and off time with slow or mixed decay section. Two amplifiers with fixed amplification factors are available for current sensing using an external shunt resistor. The adjustable slew rate guarantees the best trade-off between efficiency and EMI. The device offers a complete set of protections, including overcurrent protection, over-temperature protection, and undervolting protection. If we look now on the table on the left lower side, we see the two part numbers. The ST-SPIN 948, which comes with 4 half bridges with a voltage range from 5 up to 58 volt, and an RDS on for the high and low side of 360 milliohm. The ST-SPIN 958 has 2 half bridges, the same voltage range, and a slightly lower RDS on for the high side and low side of 330 volt. If we have now a closer look on the key applications, we see that these are stage lighting, antenna control, robotics, home appliances, and factory optimization. The fact that we are using here half bridges instead of a dedicated product for a dedicated motor, we have new driving methods. So let's have a closer look on these different driving methods the device is offering. Let's start with the ST-SPIN 948. Here on the right hand side we can see the block diagram. We can see on the left hand side the charge pump, the control logic, all the input modes with the mode pins, and on the right side the driving section with the outputs. We see the 4 half bridges, and this device comes in a 7x7mm QFM. The driving methods which are possible with this device are, for example, the driving of 2 brushed motors in both directions, or 1 brushed motor with higher current in both directions. Also have the possibility to drive with higher current 2 motors in one direction, or also drive stepper motors. We have also the possibility to drive 4 brushed motors in one direction at the same time, or we could, if we want to, drive a BLDC motor just with 3 of the half bridges. So here we see the ST-SPIN 958, and below we see the block diagram. It looks quite familiar to the 948, and from the features it's totally equal to the bigger brother. The only difference here is that we just have 2 half bridges embedded, and it comes in a smaller package, in a 5x5mm QFM package. Due to less half bridges, we have also less possibilities how to drive motors. So if we look now on the left side, we see we can drive 1 brushed motor in both directions, or we can drive 2 motors in one direction. We have also the possibility to drive 1 brushed motor with higher current in one direction. The L647X series is a highly autonomous stepper motor driver solution with 3 part numbers dedicated for applications like ATM, money handling machines, medical equipment, antenna control, pick-and-place machines, and home and factory appliances. Those 3 part numbers can be seen in the table on the left side. The L6470 offers an advanced voltage mode control up to 128 microsteps for a smooth and very silent motion, ensuring a performance similar to a BLDC motor. The 72 offers accurate positioning with a predictive current control and system stability and a low noise guarantee thanks to adaptive auto-regulated decay. The 74 offers also system stability and low noise with adaptive automated regulated decay up to 60 microsteps. All the devices work from 8 up to 45 volt and have an RDS on of 280 milliohm. They are easy programmable thanks to a SPI bus with daisy chain. They have programmable parameters and on-the-fly diagnostic. With one microcontroller, you can drive multiple drivers of this kind. They have a step clock and direction driving, integrated current sensing, which reduce the power dissipation and the PCB bomb. And they also have a digital motion engine for high-level motion commands, programmable speed and positioning. They are fully protected with real-time diagnostic, overcurrent protection, under voltage lockout, and over temperature shutdown. They are available in Power SO36 and SO28. At one point, integration can reach a limit beyond which is no longer convenient to go further with a monolithic approach. Otherwise, the silicon would become too big and the number of required part numbers would become quite immense to cover all the needs of our customers. But the demand of the market is there for more integration, and so ST decided to go with a different approach, the system in package approach. Here we use different dies and combine them in one package. This allows us to reach higher power density, and we can reuse already existing ST product, which gives us a higher flexibility to satisfy the needs of our customers. We can choose the best devices for the target application and put them together in one package. Here, for example, we can see a system and package approach where we put together the driver with a power stage to reach higher power density, and also a higher level of integration in one package. Let's have a closer look on the device behind. This is the power step 1. It's a programmable motor driver. Here we combine advanced gate driver logic, a power management, signal conditioning, 2 full bridge gate drivers and 8 power MOSFET in one package. Due to this high level of integration, we can save up to 67% of space on the PCB compared to a discrete solution, have a lower BOM cost, and an improved power density. Target application of the power step 1 are stepper motor applications like, for example, industrial and process automation, textile and sewing machines, robotics, industrial printers, medical automation, and many other applications where we are limited in terms of space on the PCB. The motor driver is a dedicated motor driver for steppers and offers a huge amount of options to tune the behavior of our motor thanks to its digital motion engine core. It works from 8.5 up to 85 volt, and thanks to the embedded 60 milliohm MOSFETs, it can deliver a current output up to 10 amp. It can work in 2 different modes. One is the voltage mode for a smoother and silent motion up to 128 microsteps, and for more precision it can work in the predictive current mode with an adaptive decay up to 60 microsteps. It offers a SPI interface, real-time diagnostic, and it's fully programmable. It has a fully protected power and driving stage, and all this comes in an 11 by 40 mm QFN package. We already saw the motor control solutions 1 and 2, and at solution 3 we integrate the intelligence. This means that we combine the gate driver with a microcontroller. When we combine the microcontroller with the gate driver, we can save space on our PCB due to the higher level of integration, and we are not limited in terms of power like we are, for example, at solution 2 with the integrated power, because our power stage stays discrete and it has a better heat dissipation.
So the next system and
Here we see now a different system and package approach as we saw before, the approach for more power density and more intelligence. The
As you can
approach
see
is called
below,
in
where we
ST
have
the
our
ST-SPIN32 approach.
STM32 combined with a gate.
The ST-SPIN32 family is a dedicated driver for three-phase BLDC motors with an embedded STM32 microcontroller. Here we combine in a system and package approach the power management, the microcontroller, signal conditioning, and the gate driver, and have an external power stage which gives us the advantage that we can target higher power application. We also reduce the space we need on the PCB up to 64%, and it's fully compatible with our STM32 environment. The family is scalable in two dimensions, the voltage dimension, so we can cover different voltage of 45, 75, and also the high voltage section, which will not be covered in this presentation, and also in terms of the microcontroller we want to use. There we have three different lines. We have the entry line with a F0, we have the mainstream line with a G0, and the high performance line with a G4. The ST-SPIN32F0 series is a highly integrated three-phase BLDC motor driver which combine a microcontroller, gate driver, power management, and signal conditioning in one package. We have three different part numbers which offer different features. We have the F0 version, which works from 8 up to 45 volt, has 4 op-amps and a whole decoding logic. The A and B version, which works from 6.7 up to 45 volt, comes with 3 and 1 op-amp. What we can see in the table in the center. All the part numbers have a gate current of 600 mA, a bootstrap diode for all the 3 high sides, and 1 comparator. The microcontroller has 48 MHz, 32 KB flash, and 4 KB RAM. The embedded power management is a 3.3 volt buck regulator which supplies the microcontroller, and a 12 volt LDO for the driving and the control section. All the part numbers have a 12 volt ADC and are fully protected with undervoltage lockout, short circuit protection, overcurrent protection, and over temperature protection. Due to the high level of integration the F0 series has, and its small package with 7x7mm QFM, the main target applications are here: fans, power tools, battery-powered home appliances, robotics, drones, and industrial automation. The ST-SPIN32G0 series is quite equal to the F0 series. It has the same gate driver, same power management, same package size, features and protections, and same communication options. So the difference here is mainly on the microcontroller side. We also have here 4 part numbers instead of 3, what we have with the F0 family. They are differentiated in a A version for 3 shunt current sensing, and so they come with 3 op-amps, and a B version which come with 1 op-amp for 1 shunt current sensing. There's also a differentiation between 1 and 2. 1 comes with a VBAD and VREF pin option, and the 2 is without. The VBAD pin can be used to supply the microcontroller via a battery when the main supply voltage is not present, and the VREF can be used to give a reference voltage to external components. Due to these different options, the amount of free GPIOs can be between 16 and 23. The G0 offers also more performance in terms of computing power, up to 64 MHz, and it has double of the size of the flash and RAM, and a more performant ADC with more channels compared to the F0 series. Target application here are equal to the F0 family with power tools, battery vacuum cleaners, pumps and fans. The STSPIN32G4 belongs to the high performance line and it's superior to the two other STSPIN32s in terms of microcontroller and driving capability. So we can target here applications up to 48 volt like e-bikes, e-scooter power, garden tools, robotic and much more. Due to the fact that this driver is working from 5.5 up to 75 volt and have a current output of 1 amp for all the low sides and high sides, and provides also a bootstrap diode for all the high sides. It also offers more analog front end, so we have 3 op-amps and 4 comparators, 2 12-bit ADCs and 4 12-bit DAC channels. The M4 Cortex inside the G4 microcontroller is with 170 MHz performant enough to run 2 BLDC motors at the same time controlled by the G4 by using an external gate driver. The G4 also offers 128 KB flash memory and 32 KB RAM and has 43 GPIOs. It has also an improved power management. So here we're using a 3.3 volt LDO to supply the microcontroller, a programmable buck regulator which supplies the driving section, and an embedded standby regulator to have a faster startup time. The STSPIN32G4 comes with the ST typical protections like undervoltage lockout, overcurrent protection, over temperature protection, and short circuit protection. But additional to that, the G4 has also a VDS monitoring to check the drain source voltage of every MOSFET and switch the application off when the set threshold value is triggered. This makes the STSPIN32 to a new unique product on the market, and it's the best fit for BLDC motors, and all this comes in a 9x9mm QFM package. If you check out st.com, we will find many reference design leveraging on our STSPIN32G4 for different types of applications. Let's come to the conclusion. Why to choose ST? Basically, there are 2 reasons. One is a product specific, because ST is offering a lot of analog and power IC solution which fits to every type of motor and every application. We also have application-specific products with a high scalability in different packages and for different voltage range, and we also offer the power management and the MOSFETs. On top on this, we did not mention this in this presentation because it was not part of it, but all the products can be paired with our STM32s, MEMS and sensors. And of course, our ST longevity program across all our product families. The second reason why to choose ST is the ecosystem ST is offering. We're offering a lot of evaluation board reference designs and all them leverage on our X nuclear boards. We also provide a lot of libraries and graphical user interfaces to make the evaluation of our products as easy as possible and to ensure that ST is also offering a bunch of product selectors, much more than we mentioned here in this presentation. More information you can find in the links you see on the screens or the links in our show notes. I hope you found this presentation useful, and I hope we see us again in some other mass open online course of ST. Ciao everybody.